All right, so this is your new homework assignment. We haven't had a new homework assignment for a while. So this is a new one. It has to do with records. So let's go ahead and take a look at the new homework assignment.
Is it as long as the one we did in class?
It's really similar.
I mean the last one.
It's similar. It's the reverse of what we did in class.
Oh wow.
Yeah.
Okay.
Well, this is the easy part. This is not the date part, which is the hard one. This is the easy part, which is the time part. So here's the algorithm. Nope, that's it. Yep, that's it. That's your homework assignment. This is what we did last on Tuesday. So we'll hide this one first and focus on your homework assignment. It's actually, you can probably do it in. The only part that's hard is to calculate all the mod and div and stuff like the division, but you can do that using a spreadsheet, which is what you're going to use to do the homework assignment anyway. So that means you don't need any additional tool to get this done.
As long as we know how to use the spreadsheets properly.
Yes.
And if we don't, it's like,
I think you guys can do it. I think you guys can do it. Okay, so we start with line 17. Line 17 goes to the subroutine. The subroutine only has one line to do anything. It does have a local variable, which is a time record, and the structure of a time record is all defined here. It has hour, minute, and second. Instead of using H, M, H, and S, I decided to spell out the names so that it's easier to hour, minute, and second. It's all spelled out. And then you invoke another subroutine called epoch to time, and epoch to time is right here. And all it does is to take one parameter passed by value, which is a number, an integer, and it takes another parameter passed by reference, which is a time record. And we are doing the exact opposite of what we did on Tuesday. So instead of giving you an integer and instead of giving you the hour, minute, and second format, you have to start with the integer and then reverse it back to the hour, minute, and second. If you don't know how to do it, don't worry. The code is already done. All you have to do is to trace it. So the first one, on line 9, is to calculate, what is the hour, and then the second one calculates what is the minute, and then the third one calculates the second. And these are all based on mod operators and also divisions. This is the number of seconds in a day divided by the number of seconds in an hour. And this is the number of seconds in an hour divided by the number of seconds in a minute. And that's just the number of seconds in a minute. To do all these calculations, you can use the spreadsheet to help you. For instance, if I want to calculate the mod of something, you can use the mod function in a spreadsheet. You start with an equal sign, whenever you want to use a formula in a spreadsheet, and then you just have to give it, the number that you're dividing, the dividend, and I can just punch in some really big number as the dividend, and then you specify the divisor next. The divisor is let's say 3600 in this case, and then you press the enter key. That will give you that particular number. And then you can either continue with this, or you can use another cell and say, this time I want to calculate the floor of something. When you use the floor, you can refer to this cell, as the first number, and then you have to specify the significance. The significance is basically saying, how many places after the decimal point do we want to, round it to. You have to give it a 1, which means we're only interested in whole units, but not any fractional units. And then press the enter key, and now you have this number as well. Oh, you have to do the division, so you have to take B21 divided by 60, depending on which part of the assignment you're doing. But this will give you an integer number, which is the floor of the result of the division. So are we doing okay so far with these tools? If you don't want to use the spreadsheet, there's no need to use the spreadsheet. You can use your own calculator to accomplish the same thing. Are there any questions about how to do all the calculations? Yep.
So after you've gone through the whole algorithm in T, it's changed to whatever. How do you write time second or time minute second?
It doesn't really write it out. All it does is to finish the calculations. So by the time you are done with the invocation, that record, which is a local variable, will be deallocated. But in the trace, I can see whether you did the calculations correctly or not. So it's all about the trace. It doesn't do any output that will let the end user see the actual time converted.
Okay.
But from the trace, I can tell whether you did the conversion correctly or not.
Okay.
Yep. Any other questions about this one? Yep. Go ahead.
So when you set up like a record, like I think can't find one, but like say T is set up into hours, minutes, and seconds. Would that
Right.
be kind of like an array? You'd have T, and then the 3 below it would be an hour,
Right.
minute, second.
There are 3 columns, and then the 3 columns will be labeled, with those names.
Okay.
Yep.
Gotcha. So like local T1 would just have question marks below them because you don't really know what it starts.
Correct. Yep. There you have it. Are there any questions about the homework assignment? You have 1 week to work on this. I think you guys can probably get it done within at the most half an hour or so. No questions about this? Nope. Okay. Very good. So I'm gonna.
Looking at it right now. If
Sorry?
I have any questions, I can ask in class.
Very good. You guys can do this only because the rest of the class is being recorded, so you're not gonna miss anything. How many of your other classes are starting to do this? Having a
I
recorded.
wish every class I was in did this. Right?
But how many are starting to do it?
None.
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 The technology is here. I could not do this before because I don't have any place to store the video for one thing, and then the second thing was the screen recording software was not very mature about 5 or 6 years ago. The only thing I could use was a commercial software called Camtasia. But these days even open source solutions are pretty easy to work with.
How big of a drive are you using for your little Linux machine that you walk around with?
It's separated into 2 halves. One half is is quote unquote a DVD-ROM image,
Okay.
but I put it onto an SD card, and that part is about 1.7 gigabytes, and that includes not only the Linux operating system, but also the GUI and all the applications that I typically use. So all of that stuff is included in one single 2 gigabyte SD card. You can put it onto a USB thumb drive or whatever, or an external hard drive. That makes it faster. And then the other component, because it's supposed to be a DVD-ROM image, so you cannot write back to it. So all the files that I'm saving are being saved to another flash drive, and that one is a 16 gig micro SD card, attached to a little flash reader like this. Yep, nothing really fancy or expensive. It was a little expensive when I bought it, but these days, 16 gig SD cards or micro SD cards are not too bad.
Yeah.
How much are those now?
Pretty cheap. I mean, even like a USB dongle.
12 or 9 bucks.
How?
Yeah.
12 or 9 bucks.
Wow, that's inexpensive compared to what I paid when I got it. Yeah, the SD card, that's running the operating system, the 2 gig one, it was only a class 4. I don't think you can even buy a class 4 2 gig SD cards now. Maybe used from Craigslist.
You can.
You still can?
They're really cheap,
Yeah.
but not compared to what you could get for the money.
Right,
If you
right.
move
If you
up.
want the most gigabytes per dollar, I think 8 gigabytes may be the best deal now. Is that the case?
Probably.
8 to 16 maybe? Because I know 32s are still kind of expensive because the demand is more, people are more willing to pay more for 32 gig, but for 8 and 16 it's commodity these days.
Well, things are moving to like solid state drives now, so that's driving up the price of all the chips. So it's like I just got a solid state drive for my laptop. So
Well, I bought a thumb drive and they gave me a 4 gig micro SD for free. They was like, here, take it.
Yep.
Sweet. It's even better.
Yep, but you only need 2 gig, for the DVD-ROM image. All right. So what we'll do now is to continue with the discussion of types and records. And just to help you with your homework assignment, I'm going to work on one little sample program, just so that you guys know, how to work on that particular program. Yay! All right. So in this particular program, I'm going to use a complex number as an example. In a complex number, now this is not a math class, so you don't have to worry about the math portion, just the algorithm portion and how it is traced. In a complex number, there are 2 components. The first component is the real number part, and then the second portion is the imaginary part. And instead of using real numbers, I'm going to use integers here just so that we are familiar with all these concepts already. And record. But this is also a good time, to kind of go for a very slight digression. How do we store real numbers? Has anyone ever thought about how we store numbers inside a computer?
You store it in binary, probably.
Well, we have to store everything as a binary something because inside the computer we only have bits. One bit is a binary digit. It is either a 1 or a 0. Now we know how to deal with integers. That's pretty easy to deal with, okay? Because it's just a base conversion thing. If you know how to express something in base 10 as an integer, it's easy to convert it into binary. Okay? Do you guys still remember the discussion of how to do simple base conversion? All you have to do is to, in your mind, imagine that you only have bills and coins that are powers of 2. So we have $1 bills, $2 bills, 4, 8, 16, and then on the other side you have coins of half dollars, quarter dollars, $8, and $16. If you can just kind of imagine a money system like that, and you know how to work with that, you already know base conversion. So base conversion is not a big deal. The question is, how do we store real numbers? Okay, try to recall from your math classes, what is a real number? How is that strange or different compared to, say, integers? Now, integers are interesting already because there's an infinite number of integers. We know that part, right? Because if I tell you that this particular value is the largest integer, guess what? Then what is this number plus 1? Don't.
It's one larger.
Yes, it is one larger, which makes the number that I gave you not the largest number. Okay, so there's no limit to integers. On the other hand, integers are nice in a way, because if I give you 2 specific integers, you know exactly how many integers are between those 2 integers. Is that right? What about real numbers? If I give you 2 real numbers, can you tell me how many other real numbers are between those 2 real numbers? There's an infinite, exactly. So that means, in order to store real numbers, we have a bigger problem compared to storing integers. A 32-bit integer can store, values from about 2 billion to positive 2 billion. Okay, a fixed number of digits means a fixed, range. That is true for any base. It doesn't matter whether it's base 2 or base 10. Because in base 10, when you fill in those forms when you deposit money in a bank, they have a certain width, a number of digits, right? So if you, for some reason, has a lot of money to deposit and you run out of those digits, then you have a problem because you cannot specify the amount that you want to deposit because they do not give you enough digits to specify the amount. Okay, and I will not ask you why you have that amount to deposit in your bank. But it's the same thing with binary numbers. If you have a fixed number of digits, then you can only store a certain range of numbers. But what about real numbers?
Set of real numbers includes all decimal places, all fractional numbers, all positive and negative integers.
Yeah, well, think of
except
some.
for, imaginary numbers.
Yep. Well, what about just pi? Just think about pi. What is the value of pi? Well, is it cherry or apricot, right? Okay, pi is 3.1415, and then it goes on forever. How do you store a value like that? It's a real number. Pi is a real number, and so is the number of days in a year. Those are all real numbers, but they are irrational numbers, which means the pattern does not repeat and is endless. Okay, and the answer is we cannot truly represent real numbers in a computer, in a digital computer anyway. Okay, we can only approximate. We can only store an approximation of real numbers. I'm not going to get into the IEEE floating point number representation in this class, but all you have to remember from this class is real numbers really cannot be represented completely. You can only store approximations of real numbers. Okay, and now we can go back to our discussion here, because that particular representation will pop up again. If you're getting into programming, it will pop up again time and time again. All right, so now we have complex numbers, and we'll go ahead and just define one subroutine to initialize a complex number. So I'm just going to say this is init complex, and if you want to initialize a complex number, the first thing is you have to give the subroutine a reference to the complex number that you're initializing. So we'll just call this C, and it is a complex number. And then you also want to specify by value, what is the real number part of that complex number, and also what is the imaginary part of that complex number. The subroutine is really easy. All we want to do is to say C.R gets the value of R, C.I gets the value of I, and define sub. And just like with your homework assignment, I'm going to give you a stub subroutine. Inside the stub subroutine, I will have a local variable, which is a complex number. So local C1 is a complex number. And I just want to initialize the complex number to a particular value. So I'm going to invoke init complex. I use C1 to specify parameter C, and then I want the real number part to be 4, and I want the imaginary part to be -6, and define sub, invoke stub, and that's my program. I'm going to trace this. Can everybody see the resemblance to your homework assignment? No? All right, so this is really easy to trace. What we'll do is, there's no need to use comments in this case because I'm not printing and there are no conditional statements. So I can start with just line number. There are no global variables, so the precondition really has nothing to say, but it still needs to be there. We start execution on line 16. It invokes stub. That means we need to remember where's our return line number. The return line number in this case is post because this is our last line of the pseudocode. But we also have to remember to allocate the storage for the subroutine stub. It has one local variable, so we have to allocate columns, in this case for C1. C1 is not going to take up one column, because C1 is a record. A record can take up multiple columns. In this case, we have to look into the record type called complex, which is defined up here. It has two components. One component is called R, and the other component is called I. So that means C1 as a variable of the type complex is going to take up two columns. There is no need for you to do the merge column thing here. I just do the merge column, so it is, it's just, easier to read because, it means C1 as a single variable spans over two columns. It has two components. All right, so this part is all done, and I'm going to shrink the columns a little bit, just like that. Then we can go into the subroutine. The subroutine stub only has one line that really matters. It's line 14. Line 14 is invoking init complex. So we'll go ahead and see how that works. Okay. When we invoke init complex, should we use return line number or return info?
Good question. What about the values for?
Oh, you're right. Okay, I forgot about that. Because it's a local variable, that means all the components start with unknown values. Very good. Thank you. Then we move on to line 14, and line 14 is invoking init complex. Init complex has several items to store in the columns. The first one is a return line number. It does not return a value, so we just need a return line number. The second one, or the third, and also the third one will be the parameters that we are passing. There are 3 parameters in this case. We have C, R, and I as parameters passing to complex. R and I are the easy ones to deal with because they are passed by value. 4 is passed to R, and -6 is passed to I. So these two are the easy ones. What about C? C is passed by reference. I'm using C1 to pass to parameter C. So that means C is a reference to C1. C1 in return uses the 2 columns C and D. So that means parameter C is also known as column C to column D. This mechanism is very similar to when we use pass by reference on arrays. Okay, except this time we are not referring to an array, we're referring to a variable that is a record. The return line number is simply line 15 because the invocation is on line 14. So now we are ready to go into the subroutine starting on line 9. Line 9 says c.r gets r. So right here we have to be careful which r has what meaning. The right hand side has a single r. The single r refers to the pass by value parameter r, which is column G and has a value of 4. So the right hand side of line 9 has a value of 4. The left hand side refers to c.r. So we have to read from left to right. C is a pass by reference parameter. It is also known as column C to column D. Within column C and column D, column C is the one that is named R. That's the name of the member inside the record. So that means on line 9, the left-hand side is just referring to column C in the spreadsheet. That is initialized to the value of R, which is 4. Are we doing okay with this step? Then we move on to line 10. Line 10 is doing something with the member I. So once again, the right-hand side with a single I, it is referring to the parameter I, which is passed by value. It has a value of -6. The left-hand side, c.I, refers to the member I of C, which is a complex number. C refers to column C to column D. Column C and column D has two components. The second component, which is column D, is named I. So this is the one that will be updated to a value of -6. Are we doing okay so far with this algorithm? It's very similar to stuff that we have done. We have already done in this class. The only thing that's new is how are we passing a record by reference. But that's really consistent with how we do things in the past. After line 10, we get to line 11. Line 11 is the end of the subroutine. It has two things to do. First, we look up the return line number. We know now that we have to continue on line 15 after this. And then the second thing it has to do is to deallocate the columns that has been allocated before. So here I will just mark that these columns are no longer used. And we're now back to line 15. Line 15 in return is another end defined sub. So we do something similar. So we copy and paste these headers, remind ourselves that we have to continue onto line 15, and also make sure that we indicate that these columns are no longer in use. And that's it. Are there any questions about this particular sample program? I would call this complex. Yep, go ahead.
We don't have to explicitly show a deallocation of components R and I of C1, just close out C1 and that's sufficient?
That would be sufficient. Yep. Because R and I are components inside C1, when you say that C1 is deallocated, that means all the components are also deallocated. All right. Any questions about this one? I'm hoping everybody can see the parallel between this little sample program and what you have to do with your homework assignment. Your homework assignment involves some more calculations, but in terms of passing by reference and how to store something into a record, that part is the same. Okay. Any questions about this? No questions? All right. So we are pretty much done with the concept of records. But the records, the concept of records, let me just open this in a new tab, and then that's the assignment. I meant to open this one. Okay. Now you can also have arrays of records. Let's finish that part up. How do we mix records and arrays? The answer is, well, they are completely different things. A record can contain arrays. An array can also be an array of records. Okay, so both of those concepts can exist.
Peanut butter and jelly.
Yep, peanut butter and jelly. But they work really well together, just like peanut butter and jelly. All right, so let's go ahead and look at another sample program. So let's go ahead and take a look at this sample program. We'll go ahead and have I'm trying to think of a student record. So we'll define record type student. And we don't really want to store the name here because I don't want to deal with strings. So we'll just go ahead and store the ID number of a student. And this is just an integer. And we'll also store the GPA, which is going to be a real number. When I say it's a real number, it's an approximation of a real number. You can store fractional parts, but not all values can be represented exactly. All right. So when we have a single student record like this, how do I represent a class? A class has many students. So how do I represent a class when this is the way to represent a student? Which concept do we want to use? An array. Very good. Now, but if I use the concept of an array to represent a class, I run into one particular problem. How do I know how many students there are in a particular class?
Array minus 1.
Bar A bar minus, well, bar A bar is the number of students. But that's the number of students in the array. But if I want to use the same structure for different classes, then it's not going to work because this class has close to 50 students. My CISP 453 class only has 20 students. If I want the same algorithm and the same code and also the same record type to work across all the classes, I need to remember that the number of students is not necessarily the number of elements in the array. Some of the elements may not be used. Okay? So this is how I would represent a class. So record class, okay? And I don't want to use the name class because it is a concept in object-oriented programming, and I don't want to make the confusion. So I'll just use section, as the class section as the name of this record. So the first thing I would do in this case is to have an array of student records, and that would be I can name the member called students, and I'll just make this an array of, let's say, 100 student records. So let's just kind of focus on this line first and make sure that we understand what this means because the terms can be confusing. Students is the name of the member. Okay? The name of the component is students. The type of students is an array of 100 student records. The second student here with the uppercase S refers to the record type student. Are we doing okay so far with this concept? It can be confusing because of this. Okay, and then we need one more field, which is the number of students in the class, and that's stored as an integer. And record. This is how we can mix up the concepts of arrays and records. We can have a member inside a record that by itself is an array. But what is it an array of? It's an array of records. Okay. Let's change this one a little bit here. Let's just change it to 3 students because I want to trace it. I don't want to use up 200 columns, for the class, so that everything is I have to scroll horizontally a few times, just to get to the end. So 3 students would be good just for illustrating the concept. All right. So now we can define a subroutine and to make use of that. Let's just say that what we want to do is to find out who has the highest GPA in the class. So find, okay, we'll just say highest GPA. What type of parameter do you think I need in order to find out what is the highest GPA of a class?
The GPA.
Well, that's what it returns. We want it to return the GPA. But what does it need as a parameter in order to figure out what is the highest GPA of a section?
By reference.
Passed by reference, a section, right? I need to know which section that I'm trying to find the highest GPA of. Okay. So that means I'm going to say by ref here, and use lowercase section as the name of the parameter, and then use uppercase section to mean the type of the section. So this uppercase S section here is the same name as the record type. Are we doing okay so far, with this program? Let's assume the array is not sorted by GPA, because I probably want to sort it by student ID so I can quickly locate those students. So this means if I want to find the highest GPA, I just need a loop. I cannot just look at the first one or the last one. I actually need a loop to do it. So I need a local I as an integer to go through the entire array. So this time I have to say while I is less than not bar a bar anymore. It has to be section dot NumStudent. That becomes the upper bound of this loop. Assuming that particular member inside a section is always valid, because someone can intentionally put a wrong value there, then I will be addressing the array out of bound. And I need something else too, because I need to keep track of who actually has the highest GPA. So here I need another local variable. There are two ways to do this. I will just use max itself as a real number. Yeah, I can do that. And it has to be initialized. I has to be initialized to 0, and max has to be initialized to something as well. There are two ways to initialize max so that this algorithm will work correctly. You can initialize max to the smallest value that you can represent as a real number. So that way, the first student we encounter in the class should update max to be the grade of that particular student. But a better way to do this is simply to say that the maximum is just section dot students bracket 0 dot GPA. Now,
that way it's the first student's record already, and you're skipping a step.
Yep. We have used this approach before already, just not in the context of a record containing an array that contains records. All right, but we want to kind of focus on this part just for the time being and find out what that means. Okay. Once again, we read from left to right. There are only very few occasions where you have to read from right to left. Okay. Does anyone want to know, under what situation you have to read from right to left?
Sure. When you're assigning a value, basically.
Well, when you have negation, the negation of something, that's when you have to kind of read it, in a reverse order, because the operator is before the thing that it's supposed to operate on. But in this case, you just have to read from left to right, and just read it one portion at a time. Okay, we'll read it one portion at a time. What is section in this case? What is it referring to?
The record by ref section.
It's referring to a parameter. See, we have a parameter by reference here. Section with lowercase is just referring to the parameter. The parameter is a reference, but it's a reference to a section. So that means, what is the second one? What is this portion referring to? Where do we find this name, students? As a name of the member inside a section. It's right here. So that means when you combine these two, it simply means the student's member of the parameter section. Is that making any sense? But when you look at this together, what is the type of this thing, the portion that is highlighted? Is an array, right? I know it's an array of 3 students, but at this point, I don't even need to know what kind of array it is, or what is the type of the elements inside the array. All I need to know is it is an array. What can you do with an array? You can take the bar notation, to know the number of items in the array. You can also do one more thing with it. What else can we do with an array? We can use the square bracket notation to say that I'm not interested in the entire array. I'm only interested in one element of the entire array. So that means now I can say, hey, I'm only interested in the first element of the entire array, because bracket 0 is only referring to the first element of the entire array. What is the first element of this particular array? What is the type of the element? It's a student. It's a student record. Because according to this definition, students inside the section is an array, but it's an array of 3 students. So by the time we are done with the indexing, we'll be left with a student type. Now with a student record, what else can we do with a student record? We can break it up even smaller into either the ID or the GPA. So that means, the dot here is just saying, okay, what portion of a student record do I want to access? I want to access the GPA portion of a student record. So is that okay? I mean, does everybody understand how to read this chunk of code? Is that okay? All right. So in the loop here, I just have to maintain the maximum. I have to find the maximum. For efficiency purposes, I can change this I from initialization from 0 to 1. It's not wrong to start with 0. It's just for sure that the first iteration is not going to do anything because we already start with the GPA of the first student, and the first loop is going to compare to the first student's grade GPA. So the comparison result is already known, and there's no need to go through the first iteration if I make I start with 0. So making I start with 1 means that I'm going to start to do something useful in the first iteration of the loop. So we have to say if section.students bracket I, in this case, dot GPA, if this is higher than the maximum GPA that I know already, then I should go ahead and update the maximum, because the maximum that I know so far is really not the maximum anymore. So we just say that it is now updated to the GPA of this particular student, and if I gets I plus 1, so I can move on to the next record, and while, and then all I want to do is to return max in this case, and define sub. It's time to fix all the indentation. Okay. Are there any questions about this particular subroutine? All it wants to do is to say, give me a section, a class, and I will try to figure out what is the highest GPA in the class, and then return that GPA to whoever is calling this subroutine. It does have one flaw. It doesn't handle one particular case. Can someone name the case that it cannot handle?
2 people on the highest. 2 people on the highest.
Well, if there are 2 people of the highest GPA, it will still return the right GPA, because we're not returning who has the highest GPA, so it's still okay. The only case this cannot deal with is an empty class. What if there's 0 enrollment in a particular section? It makes an assumption that we have at least 1 student in the section. Okay. Now, if you don't have any students in the class, what do you think it should return? What is the highest GPA of a section when there are no students enrolled in that section? 1. It's undefined. We don't know. So that means, by definition, this subroutine really cannot return a value when there are 0 students in the class. Okay. Now we'll go ahead and just test this program. This time we'll use a global variable just so that I don't have to go through the initialization. I can just give you a section that is already initialized. So in this case, we'll just go ahead and print invoke highest GPA. I would use a global variable in this case, and the highest, the global variable is going to call cisp300. This class, which only have up to 3 students, and I will pass this to parameter section, and whatever it returns, I'll print it out. And that's the entire program. Now we want to know, what happens, when we try to run this program. How is a section represented in columns? That's what we want to find out first. So we'll go ahead and use sheet 2 to represent that. We need comments in this case because we do have conditional statements, loops, and also print statements. Then we have line number. And this time the precondition has quite a few things to say, because we have to explain what the section is for cisp300. Yep.
Why don't you start with 1 being all the way at the top?
Say again?
Why don't you start with 1 being at the very top of your program, like record students?
You mean here on
No,
line 10?
At the very top, like scroll up. Like there's more numbers.
Oh, I forgot. We never really have to trace those lines, so technically, it's okay the way it was, but it's an oversight. Okay. All right. So now, what does it look like? What does a section look like in terms of columns? Well, let's find out. cisp300 is a global variable of the type sections. So what we have to do is to look at section and find out in the section we have first an array of 3 students, and the element, or excuse me, not the element, the member is called students. But inside students we have 3 array elements. We have bracket 0, bracket 1, and bracket 2. Inside each element we have ID and GPA. So we got ID, GPA, ID, GPA, ID, GPA, like that. And obviously we have to shrink the columns a little bit, because otherwise we can't really see the entire thing. All right, so students is actually, okay, if I want to use the merge columns or merge cell to represent, what is the extent of each thing? Element 0 actually has 2 columns because it is a student record. Element 1 has 2 columns. Element 2 also has 2 columns. Students, which is an array of 3 student records, now has 6 columns. Are we doing okay so far with the breakdown of the components? Okay. Now besides students, we also have NumStudent, which tells me the actual number of students in the class because the size of the array is fixed. That turns out to be a single column only because it is just an integer. It says right here it's an integer. So that means when I want to look at the entire extent of cisp300, which is a section record, it actually has 7 columns, like that. Are we doing okay so far with this picture? So if I want to make this look nice, I can merge these columns too, so that we know that NumStudent is just NumStudent, it has no subcomponents. Now we'll go ahead and try to initialize this thing. So we'll go ahead and say ID 7 digits, has a GPA of 3.0, and this ID, too many digits, has a GPA of, well, since we are trying to find the maximum, we'll make this 3.4. And the number of students in the class is actually only 2. In other words, even though the array has a capacity to store 3 students, this particular section only has 2 students. Are we doing okay so far with the structure of how we represent data? Okay. So this is our precondition. Our precondition is pretty long. Then we can move on to the program, starting on line 23. Line 23 is going to try to do the printf, a print statement. But the print statement cannot know what to print until the subroutine invoke highest GPA is done. So now we need a return info because we are returning back to line 23 itself. When we get back to line 23 itself, all we have to do is to print the value that is returned. Yep.
Do we not have to put anything then for ID and GPA in element 2 when we initialize?
You can put question marks.
Okay.
Yeah, because we don't know what it is. Very good. Good point. And then when we invoke the subroutine, we also have to allocate columns for all the components. The component call section is passed by reference because this is the name of the pass by reference parameter. It is also known as, let's see, we have 7 columns C to I here. So this is also known as column C to column I. And then we have our local variables. One is I and the other one is max. And because they are local variables, they all start with unknown values initially. Are we doing okay so far with this? And now we are ready to go into the subroutine, start to execute on the first line inside the subroutine. And it's a good time to split the screen horizontally so that we can keep track of the execution point on this side. So we are now starting on line 13. Line 13 is just initializing the local variable I to 1. Line 14 is initializing max to the GPA of the first student. So now we have to go back here. Okay, let's do it step by step. We are focusing on line 14. Line 14 wants to initialize max with this junk here. We are looking at section. Section is a pass by reference parameter. It is referring to column C to column I. So now we have to track down column C to column I. Column C to column I turns out to be a section record type, and students is the first member of the entire record. It is an array. We are only interested in the first element of the array, so that means we're only interested in column C and column D. But not only that, of that one record, student record, we're only interested in the member called GPA. And GPA is column D, it is 3 in this case. So that means when we are done with the initialization, max will have a value of 3. Are we doing okay so far? Tracking down everything?
Earlier you called max by reference.
Oh, did I did?
Is that?
Yeah, max is a local variable.
Okay, thank you.
Okay, after line 14, we go to line 15, which has a condition to evaluate. The condition that we are evaluating is pretty long, so this is not going to fit either. I is less than section.NumStudent is what? It is false. Oh, it's true, sorry. It is true because when you look at section refers to column C to column I. Within column C, which is here, to column I, which is here, column I is the one that has a name of NumStudent. So when we say section.NumStudent, we are referring to column I, which has a value of 2. I has a value of 1. 1 is less than 2 is true. So that means we have to go into the loop on line 16. Line 16 is going to go through a comparison. It's trying to compare the GPA of student bracket I this time is 1, of section, and compare that to our max. Section refers to column C to column I. Within column C to column I, we have a student's member. Within the student's member, which is an array, we have an element, bracket 1. Within bracket 1, the second element of the entire array, its GPA is 3.4. 3.4 is greater than max is true because max is 3. So that means this entire condition is true. So section.students bracket I dot GPA is greater than max is true. Are we doing okay so far, even though the actual condition is truncated because I can't display everything at the same time? Well, I kind of can, except, I'm not sure of whether the wrapping around is helping or not, but we can give it a try. So we can go to alignment and turn on wrap text automatically. So this way we can see the entire thing, except it is kind of not truncated, but wrapped around. After line 16, we go to line 17 because the condition is true. Line 17 is just updating max with the member that we just saw, which we already know, which is, that's 3.4. Then we get out of the conditional statement onto line 19. Line 19 just wants to increment I by 1. So I is now incremented to 2. We go back to the beginning of the loop, which is on line 15. And this time I, which is 2, is less than section.NumStudents. NumStudent is false because they are both 2. 2 is less than 2 is false. And that will get us out of the loop. We go to line 21. Line 21 is a return statement. Max is 3.4. So we copy and paste the return info cell, change the question mark to 3.4. And then we get to line 22, which is the end of the entire subroutine. At the end of the entire subroutine, there are 2 things to do. One is to remind ourselves where to go next. It's 23, back to line 23, but it looks like this at this point. And then the other thing we have to do is to deallocate all the columns. So we deallocate all the columns here. And then we are now back onto line 23. Line 23 looks like this, which means we are ready to actually just print the value of 3.4, and we're done. Are there any questions about this trace?
At any point, did we even evaluate bracket 2?
No, because bracket 2 is not. Okay. Let me just make this maximize this screen here, so that we can see better the entire trace. Okay. We do not do that. Okay. Let me just shrink some of the columns that do not need to have so much space on the screen, so we can kind of focus better on what we want. Okay. The third element in the array is quote unquote uninitialized because the class only has 2 students. So the third slot in the array actually has no student to represent, and therefore what value it has doesn't matter to me because I'm not going to look at it. And that has to do with NumStudent is already 2, telling me that I really only should be paying attention to the first 2 elements of the array. And that's why in the loop, when you look at the algorithm itself, it wants to stay I has to be less than NumStudents the NumStudent member of a section in order for this to make sense. Yep, go ahead.
But because the students is of a type of array of 3, then that's why we have to put the 3.
That is correct.
Okay.
Yep, the array has the room for all of that stuff. It's just that I don't know what the value is, nor do I care. Yep. Okay, go ahead.
Well, just to further what he was talking about, is that then why we included NumStudents in that array
Correct.
instead of using RA bar, because using RA bar would lead to problems.
Correct.
So we just kill that by ignoring it.
Yep, that is correct. Yep, go ahead.
Okay. How come we started I as 1 from here, but never searched for the first student that 3.0?
I do not need to because the way max was initialized. Because max was initialized to be the GPA of the first student in the array, that's why I don't need to start with. Okay, just imagine this. What happens if I change line 13 so that it is I gets 0? What do you think would happen? What happens on line 16 in that case? I equals to 0. So on line 16, what am I comparing? Do we know the result of that comparison regardless of the values in the array? It's going to be false because we're comparing max, which was initialized to exactly the same value, to itself. So we know that it's going to return false, which means we're not going to update max and just move on to the next element in the array. So why even bother to compare when we already know the comparison result? We'll just go ahead and skip it so that we start with the second student. In terms of the English explanation of this algorithm, what I'm doing here is I'm assuming, before I have any further information, I'm assuming the first student in the array has the highest GPA. But as I continue to look at the GPA of other students in the class, I will go ahead and update the maximum GPA in the class. That's basically how I can explain it, or the method that I'm using in this algorithm. Is that okay? Okay. All right. Any other questions about this? No other questions? Okay, so let me save this file because I think it is kind of important.
Isn't it 26?
Oh. It's not sorting by.
Oh, it is. Yeah.
Faster download.
Oh, because of the download. There we go. And we'll change this one to max GPA. All right. So let's go ahead and close this. So technically speaking, we are done with all the topics that we have listed so far. So what I'm going to do at this point is to kind of go a little bit beyond what we have talked about so far and step into, well, we'll do abstract data type first. Okay, so this is stuff that is really extra, but I think will be very beneficial if your intention is to go to cisp360 and programming in general. Okay. Let me show you, this code first. So at this point, I'm not going to spend some time to trace the program. I'm just going to use the source code and describe the concept, because at this point, what I'm trying to describe are programming discipline. In other words, what you should and should not be doing when you're writing programs.
So is any of this stuff after now, is it going to be on the final?
It is not going to be in the final unless it is a clarification of concepts that we have already went through. So we still have arrays and records, that will be in the final, as well as passing by value, passing by reference. So all of those concepts can combine in any way in the final. But anything that is not a reshuffling of those concepts will not be in the final. Okay. All right. So what I'll do is I'm going to define, write a program, very simple program to do certain type of things that I want to do in two-dimensional space. How do you represent a point in 2D space?
X and Y axis.
X and Y, okay, that's one way. Okay, so we'll say coordinate, which is a record type, is fairly simple. We want to know what is the X coordinate, and we want to know what is the Y coordinate and record. Okay, that's fairly simple to do. All right, so when we have something like this, we can have an initialization subroutine. Well, let's not even use an initialization subroutine first. Instead, we'll go ahead and use, we'll just refer to X and Y. Okay. We'll have a subroutine, define sub, draw dot. Okay. Draw dot is going to have one parameter passed by value or reference. It doesn't matter one way or another in this case. And we'll just call it a point. A point is a single coordinate. And what draw dot, how it does that, how it draws that one dot on the screen, I don't even care, okay? So we'll just say, some logic to draw a dot on screen, because that's not the focus of this discussion. And define sub. Okay, that's done. Okay, next I want to know how to draw a line. Okay, so we have another subroutine here. Sub, draw line. Well, when you want to draw a line, how many coordinates do you need? 2. Very good. So we say by either by ref or by val. Okay, doesn't matter which one. We have point A and point B, both being 2D coordinates. Okay, are we doing okay so far? Okay. How do you draw a line?
Start from one point.
You start from one point and then you move on to the other point. But what if these 2 points are not on, the x is not the same and the y are not the same of these 2 points? It's a slope. So you have to now calculate what is the next dot, where's the next dot, where's the next dot, right? Well, it's not really as complicated as most people think it is. So we'll just say that we have a local variable x here as an integer. We'll make the assumption that point A is has an x that is lower than the x of point B. So we'll make certain assumptions. We'll also make the assumption that the slope is less than 45 degrees. Okay. So this way, we can do the calculations pretty easily. So we want to say x starts with a value of point A dot x, and then we'll say while x is less than or equal to point B dot x, which is the second point, the x coordinate of the second point. We'll do the following. Now we want to draw a dot, exactly where we want it. So we can now say by val, not by val, local, point to dot to draw is a coordinate. Okay, so dot to draw dot x is going to be my current x in the loop. What about the y? Do you guys still remember how to draw a linear line using the slope and stuff like that? No? It's been too long. Okay, come on. You guys can do it.
Y sin x plus b.
Okay. Okay, what is the slope in this case? The slope is going to be point B. Let's see, the point is delta y divided by delta x. So it's y minus y divided by x minus x. That's the slope, right? And then you have to multiply, let's see, you have to multiply x minus point A dot x, which is the amount of horizontal distance that we have traveled so far, to the slope, and then plus the intercept, which is really just point A dot y. Are we doing okay so far? There's a whole lot of references to x, y, and so on and so forth, but that's how we do it. Okay. Then once we figure out what is the x coordinate and y coordinate for that one dot that we are trying to draw for this entire line, we can now invoke draw dot to finish up the operation. So we invoke draw dot, and then we want to use dot to draw and use it to specify parameter point. And then don't forget the last one, because if we just do it like this and end while, it will keep drawing the first dot forever. So we have to remember, okay, let's move on to the next dot. The next dot is just saying x gets x gets x plus 1. And now we can move on to the next one. When it's all done, it's ion define sub. Okay, not too bad, okay? Except for one thing. Okay. I think I'm referring to dot x and dot y in too many places of this algorithm. Okay, why? I mean, these are all necessary. How can we avoid using dot x and dot y? And why do we want to even think about not using dot x and dot y? Well, let's forget about this program, and we'll focus on the remote control of the projector and the projector itself. What is inside the projector? Okay, there's something that emits light, and then something to filter the light, so that we can have different dots of different intensity on the screen. Okay. Do we care how it works? As far as I'm concerned, as a user of the projector, do I care whether it's all done by magic, or done by super duper technology, or what? No. It can be LCD based. It can be DLP or digital light processing based. It can be just magical. Right?
Trolls and fairies.
Yeah, trolls and fairies, doing all the blinds and louvers and little beacons, lights and glances and stuff like that. But as far as I'm concerned, if this works, that's all that I care. Okay? It's the same thing with your television at home. Okay? I think even at this point, I think most of you still remember what a CRT was. See, if I keep teaching this class for another 20 years, I can no longer refer to CRTs, because people will just look at me and go like, huh? What is a CRT? Show them a picture of a CRT, they will go like, oh, you mean a fish tank. Okay, so, but in those days, but with a television like that, what is the technology behind the television like that? It's a CRT. What is a CRT? Yeah, it's basically an electron gun, right? It shoots out electron at a high speed and then use magnetic field to deflect the electron so that it will land on different spots on the screen. And by changing the acceleration of the electron, you can also change the intensity, of those dots. So it sweeps, the beam across the screen at a very, very high rate, and as it sweeps, it changes the speed of the electron, and therefore it can change the intensity of the dot, and you see an image, because our eyes can only refresh, I guess, 20 times per second, but the refresh of the screen is a lot faster than that. So to us, it looks just like a stationary image instead of a dot sweeping across the screen. Flies would see it differently because I think the eyes of a fly has a much higher refresh rate. So when we get into a classroom like this, we see the fluorescent light as constant on. A fly would actually see flickering on, off, all the time because their refresh rate is so much higher than our eyes.
Flies.
But it makes sense too because how many people can swat a fly by hand?
Not many.
You can sometimes, okay. With certain flies too, it depends on the fly as well as you, right? And that's because the flies has such a high refresh rate. It can tell motions, things that are incoming a lot better than we can. And other insects that catch flies also can respond just as quickly, like dragonflies and stuff like that. But anyway, do you ever have to open up the television to change the brightness of the picture?
Sometimes.
I think I have to open up the case of the television and tweak this little pot, potentiometer, and change the intensity, the brightness of the screen.
It's a good way to get bed opening after TV. Because those tubes stay charged even when they're
Yes, and when we talk about high voltage, it is high voltage back in
knock
those
you on your
days.
butt.
Hmm?
I said it'll knock you on your butt.
Yep, it won't kill you though. Just give you a good shock. Okay, so after that, what is the next next television technology? We have plasma TVs. Okay, plasma TVs have a different way to control the intensity. Do you have to know how plasma TVs work in order to change the brightness of the picture? No. And then comes LCD displays. Do you have to know how LCDs work to change the brightness of your TV? No. What about the tuner side? We used to have analog tuners, and now it's digital TV. Do you care? Well, as long as the picture looks better, I don't care, right? With digital TV, the nice thing is it is sharper. The bad thing is you either get it or not. The older TVs, you can get a lot of noise, but you can still make up the picture. With digital TV, you either have it or you don't have it. There's no, oh, I have a fuzzy picture. No, you don't get fuzzy pictures. You either get a picture or not. Okay, but for the most part, we don't care about the technology. We don't care about how it is done, and why don't we care?
Because it works.
Because what works? The
Technology.
remote control works, right? As long as the power button turns it on and turns it off, the channel button changes the channel, and the volume button changes the volume, and the on-screen display changes all the other parameters as you want it. We don't really care what is inside the box. Now, how does that have anything to do with programming?
Because once you're doing programming, you have to know what's inside the box.
You want to minimize how often you have to look inside the box. Now, what box are we talking about, and what do we mean by looking in the box? This is the box. Okay, the box is a container. In this case, it is a record type. It is a container of some kind. The fewer times you have to know that it has a member X and a member Y, the better. But don't we really have to do that in this program? Because in order to draw dots, don't we have to specify the X and the Y all the time in order to draw the dots? Yes and no. Okay, we are used to the XY coordinate because that's how most displays work. This is a projector. It definitely is an XY type of device because we have rows of dots, and then we have one single row has a whole bunch of dots, and then we have rows and rows of these dots to make up an entire screen. So it makes sense in this case to use the XY coordinate. In what situation do you think it doesn't make sense to use the XY coordinate approach? Have you guys seen spoke lights for bicycles? No?
Yeah.
Really? Okay, it's time for YouTube. Yeah, I know how much you guys like YouTube, so we'll do that. Alright, so we'll look for spoke, bicycle.
Sons of guns. That looks interesting.
Little shooting thing, huh?
Been watching shipments.
Yeah.
Shooting rabbits with a shotgun, that would not be a very good idea.
Dragon's breath ammo.
Why is it recommending that? Yes.
Give some more.
Yeah, somebody is using this account to browse and stuff.
Sure. Fight the murder, aren't we?
I believe that
Sniper.
tactics into guns.
Shooting feral pigeons is a day-to-day terrible.
They're almost good.
Again, rabbit hunting.
Some rabbits.
Okay. So let's take a look at. I'm trying to find one that is really interesting, like Pac-Man. See if I can find Pac-Man here. Pac. Does any one of these mention Pac-Man?
Nope.
Nope. There's one down there.
Okay. We'll just do a general search then. There we go. And I think there's an animated version of that too. So let me see. This one is not animated.
That's still pretty awesome.
Okay, so I'll just go ahead and explain what we are seeing here. Some of you, especially if you sit up in the front, you can see the bicycle that's upside down. Okay, and people in the back, or if you cannot, the contrast is not really that good, so you can't really see the silhouette of the bicycle. So what happens is, these two wheels are spinning at high speed, just like when you're riding your bike. And there's a bar that you can install on the spoke, and the bar has is an array of LEDs. So in one case we have an array of blue LEDs, and in the other case we have an array of yellow or amber LEDs. Now when you have an LED bar, you can control the on and off of each individual LED as the spoke or as the wheel turns. And the pattern of Pac-Man and the ghost here are generated by turning on and off the LEDs at the right time when the spoke turns. Okay? Yes?
They have those for rims on cars too.
Yeah, they do. I've seen those.
Not just the.
No, they're screens. They go in the rims basically, and you can program each tire to be a different image if you want, or
Okay.
doing video.
It has like Coca-Cola, ads on it.
Okay. It's the same concept. It's definitely the same concept.
Would you not have that on your car?
It has like an entire screen.
I see. Now, when it goes onto a car, you can also add, a spinner to it, so that people can see what you're trying to display, even though you have stopped. Because the spinner will continue to spin, right? I'm not sure whether it's energy efficient or not, but it would be kind of cool. Otherwise, it would be kind of hard to explain to a cop and say, I have to drive this fast for this effect to be visible, right? Because if I drive too slow, then the people cannot see the actual pattern. But what does this have to do with what we are talking about? Okay, think about this, and think about the program that we are talking about here. X and Y doesn't make sense anymore. Okay, what would make sense when we have the spoke lights and you want to draw
you have to know the
things?
speed of rotation, and then you could.
R and theta, the radius and the angle. Okay, R and theta. So that means, when your boss tells you and say, well, I'm really happy with your program that works really well with a two-dimensional LED display, but now we want to switch to a new product, the spoke-like product, and we want to use the same programs or the same library of programs to make use of the spoke lights. Guess what you have to do? Now you have to do something like this. Okay, let me just copy and paste because I don't want to lose this portion of the program. Okay, so what you have to do now, okay, after the boss changes his or her mind, what you now have to do is to say, oh, okay, we cannot really use X and Y anymore. We have to use the radius, and also theta, which is an angle, theta, in order to represent a dot in 2D space. What else do you have to change? Just about everything else.
Awesome.
Yeah, so all of this stuff here, you have to change. Isn't that a bother? I would call that a big bother. But how do you avoid it? I mean, isn't that something that you have to do? Well, think about it again. Think about, instead of using something .x and something .y all the time, what if I define subroutines to do it? We have another 3 minutes or so. I think we probably have enough time to do it. Okay, so what we'll do is we'll define a subroutine called coord, which is the name of the type, get x. Okay. In other words, I don't care how a coordinate is actually represented in the record. I want to get the x coordinate out of it. Okay. So in this case, in the previous case, let me define sub. In the previous case, it's really easy to do, right? Because by reference C as a coord, all I have to do is to say return c.x, because it was internally represented as x and as an xy coordinate. But in the new program, okay, we have by ref c as a coord. Well, this time it's not as straightforward, but I can still return the value, because the x value is really radius times, let's see, x would be the cosine theta. Is that making any sense? Now, why would that be helpful? Because anytime I want to refer to the x portion of a coordinate, I can just replace this with an invocation of coord get x, and I don't have to worry about the actual representation of a coordinate.
Wouldn't it be a c dot radius and c dot theta?
Yep, you're right. I forgot about that. Because they're all members of the parameter. Yep. But the main concept is I have isolated the consumer of the coordination type from the producer of the coordination type. Coordination type. I can change this all day long. All I have to do is to change coord get x, and then the logic to draw a line does not get affected anymore. Okay, that's basically your remote control. Okay, the subroutine called coord get x is your remote control. All you have to know is to turn how to press the power on button. The exact detail of how to get things done is inside this box, and I don't care what is inside that box. As long as the remote control works, that's all that I care. This approach of writing programs to avoid looking into the actual structure inside a record is called abstract data type. So we'll continue this discussion next Tuesday.